Hello guys, welcome back to the channel. This is our third video of the forces series, and we're going to pick up from where we left off. If this is your very first time joining the channel, please take some time to subscribe to the channel and also press on the notification bell so that you receive notifications when I post new videos. Okay, so in the previous video, we were talking about resultants of forces, which I started saying that I see, or you should see forces, resultants of forces as just a leftover force. And we've got to know that resolving forces in the x direction is basically forces to the right minus forces to the left. And resolving forces in the vertical direction is going to be forces to the top and minus forces to the bottom. Now, let's try to combine this in a typical, let's say, A-level setting question. Let's say there is this force of magnitude 10 newtons. Let me put 10 newtons over there. And there is another force of magnitude 15 newtons. And finally, let me add one more force to it. Let me add one more force to it, I think. This won't be bad. Sorry. No, let me. Okay, this won't be bad. Okay, let me put in some angles. Let's say this is 30 degrees. This is 15 degrees. And this is like 60. No, that's gonna be 60. Let's say that is 10 degrees. Okay, so sorry about the interruption. Now, in this case, you can see that it's quite complicated when compared to the previous one because we've got forces moving in the vertical is not really like a vertical direction, not really like horizontal direction also. Unlike the previous video where you could see that the forces were just either straight on the x-axis or straight on the y-axis. You can see there's some level of inclination to these forces. So this is where the resolution of forces comes into play. Now we need to break the forces into components so that we get the x component and we get a y component since we are used to working with the x and y. Now breaking down this force, let's say the 10 Newton force, sorry, I left the magnitude of this. Let's put 20 Newtons over there. Okay, breaking up this force, I can say that movement to the side and moving to the top. So let me put in the arrows over there. So this goes that way, this goes that way. Okay. Now, as you can see, the vertical aspect of this force, because it directly faces the angle given, in this case, angle given is 30 degrees, I can say that the vertical component of the force is going to be 10 newtons sine of 30 degrees. And the horizontal component is going to be, let me use a different color for that, let's say black. There's going to be 10 newtons cos of 30 degrees. Okay, good. Now we're going to do the same for the other forces. Let's go to the 15 Newton force. Let's break this into components. So this goes in this direction and this goes to the top. This is crazy. Let me do it all. Sorry. Okay. So that I get the 90 degrees fill. Okay. Why is this thing? Okay. Anyway, let's assume that that is 90 degrees. No, that is not 90 degrees. You can't just assume like that. Let's do the right thing. Why is this thing? Oh God. I don't want autocorrect. Seriously. Please let me change the settings to my lines. Okay. Sorry about that. Okay. So yeah, breaking down this force, this goes to the side and this goes to the side. Again, the aspect of the force facing the angle under consideration takes the sign. So in this case, there's going to be 15 newtons sine of 15 degrees. And this side is going to be, let me use a black ink, that is going to be 15 cosine of 15. So that is very good. Now you can see that we've got forces to the top, that is vertically, and horizontal forces. So this will be very easy to work with. Let's do justice to the last force and see how best we can handle it. So there's going to be a force in the direction going down, and there's going to be one going towards the side. So in this case, there is a force going down and there's a force going to the side. Now, for the horizontal component of this force, we can say that that is going to be 20 because the force directly faces the angle. It's going to take sine of the angle. And the vertical component of that force, that's a 20 Newton force, is going to be 20 cosine of the angle. So after breaking these forces into components, all you need to do is to now go back to our resolution of forces, which we said that the resultant in the x direction or the leftover force in the x direction is basically all forces going to the right minus all forces going to the left. In this case, we've got two forces going to the right. Is it two? Yeah, I think so. We've got this force going to the right, and we've got this force also going to the right. And we've also got this force going to the left. So in the x direction, we've got a lot of forces. So two going to the right in this direction, and one going to the left. That's why it's very important to indicate the directions when you complete the force diagram. So just by applying the formula, we can say that forces to the right, in this case, we've got two forces to the right. The first one is 10 cos of 30 degrees. And the second one is 20 sine of 10 degrees, 20 sine 10, minus the force going to the opposite direction, in this case to the left. This is going to be 15 cos of 15 degrees. So all you need to do is just get a calculator and you input all this over there, and that gives you the resultant in the x. But this should be 10 cos 30, which is I think 5 root 3 or so, plus 20 sine 10 minus 15 sine 15, sorry, cosine of 15 degrees. So the leftover force in this direction is actually, this is quite strange. Well, let's see if we place everything in. Well, okay, so we did everything that we were supposed to do. Yes, and that is negative 2.35. So negative 2.35. Let's confirm this. Let's say 5, 6, 2, 4, 6 figures or 3 decimal places. So that's the leftover force. Now you can see that even though we had two forces in the x direction, the positive x direction, you could see we got the final answer to be negative. So it doesn't matter the number of forces you get in the particular direction. That doesn't mean the object will move in that direction. We getting the negative value for resultant in x means that if the object is to move in the x direction, it's going to move towards the left. That's what the negative indicates. So let's move on to do that of the y, resultant in y, which you know is forces to the top minus forces to the bottom. In this case, there are two forces to the top and one to the bottom. So we've got this force to the top, that's a 15 sine 15, and we've got a 10 sine 30 to the top as well. And we've got this force to the bottom. So we're going to apply the same principles and do justice to this question as well. So in this case, the first one, let's say 15 sine 15, 15 sine 15 degrees plus 10 sine 30 minus 20 cos 10 degrees. Let's pull out a calculator and let's input all this on the calculator. Okay, so I don't know why my calculator, okay, it's in now, sorry. So 15 sine 15 plus 10 sine 30 minus 20 cos 10 degrees. Okay, this will give you a negative 10.814. So a negative 10.814. So basically, this is what we're getting for the resultant in X and resultant in Y. In our next video, we're going to talk about finding the magnitude and direction of the resultant force. We've gotten the resultant all right. Now we're going to look at finding the magnitude of the resultant and the direction of the resultant force. Thanks for watching. Meet you in the next video.